I am Taryn Blake, Community Engagement Program Manager for our Siemens software community. I'm your host for this enablement session. As you can see, we are here for our Technomatics virtual user group, and our topic for today is cross-sliding cars, or CSCs. As most of you probably already know, our presenter for the session is Mr. Stefan Bongso, who is a freelance simulation expert for many years, and he's been working with us in the Siemens software community for a few years now as well. So if you need a book on plant simulation, he does have 5. He is publishing at least one more that he's working on now. And we definitely appreciate him and all of his contributions for Siemens PLM. Our agenda, the big steps for today, he's going to go through some CSC use cases. He's going to show the plant simulation library object for these, and then talk about creating custom CSCs. So that will be good. And then, as mentioned, he's going to do that live, and then we'll do Q&A live. So definitely take notes and get ready for our presentation today. So Stefan, feel free to steal the screen.
Hello to our new webinar number 41. And today it's cross-sliding cars. I guess you know what it is. You need a cross-sliding car if you have, for instance, 2 conveyor elements. So I start with a very small example. We have 2 conveyor elements, and these conveyor elements are not in a row. They have some offset, maybe here in a Y direction, and you need to transfer the part from one conveyor to the other. And therefore you need a connection between a transfer in 90 degrees from the original conveying direction. And technically you have several options, and the most common options are cross-sliding cars. Now you have a car that transports this part to the next conveyor and moves there to the next conveyor. Or you have chain conveyors, where you have a chain here on a button, and then you lower the part on the chain, and the chain transports the part to the next conveyor. Then you lift the part again and then transport it to the next conveyor. A chain conveyor doesn't need to come back. The cross-sliding car needs to move back to realize the next transport. So here we are creating cross-sliding cars, and Plant Simulation offers a cross-sliding car inside of the Cranes and More library, and this is the first one. So we need to add first the Cranes and More library to our class library, and this you can do with Manage Class Library. You'll find the Cranes and More library here in the tab Libraries, Cranes and More, and then you get the Cranes More library here under Application Objects, and the Cranes More library contains cranes, of course, and also the gantry loader. The storage crane or storage area, you can connect it with the multi-portal crane. And you have here the cross-sliding car, then a lift, vehicle lift, and the chip crane. These are all elements in this Cranes and More library. And I want to show you today the cross-sliding car. So it's quite easy. It depends a little bit on which version you have. The cross-sliding car works differently in different versions of Plant Simulation. I guess this what I show you is since 60.1, I guess. here you need to connect the cross-sliding car with connectors with all the conveyors you want to connect. So I need connectors here from this to the cross-sliding car, from the cross-sliding car to the next conveyor. And you need to set the destination attribute of the part to, yes, if you, for instance, have two exits here, to specify the exit you want to use for the transport. And so at least we need here exit control. In this conveyor. Very easy. We need only to specify the destination of the transport. And this is conveyor 1 in my case. And that's it. You need to, if you have several destinations, you set the destination for this part, and all functionality is done by plan simulation automatically. Okay, I set here an interval of maybe 5 seconds. And it's working. If you double click on the cross-sliding car, you have some settings you can do here: car length, car height, car speed, capacity, and so on. And some dumping time, 12 times, and so on. Okay, the base of this is also a conveyor, and the basic control is here a pull control, and exit, entrance controls, and so on. And because it's the pull control, it doesn't work if you're going backwards. If you transport backwards, then it doesn't react here on the cross-sliding car doesn't react on the part that's here and the backward exit control, for instance. And the pull control only works with a predecessor and only in direction of transport. And so you have, maybe you need to create your own cross-sliding car if this behavior is not sufficient for you. Maybe you need to turn the cross-sliding car while moving to change the direction of the part. And so you need to create your own cross-sliding car. And I want to show you this on the case that you have to transport backwards. So I make a very simple example for this. It's the same like here. I have conveyors. Oh, the wrong side. I have another conveyor. The source is here, and the train on the other side. I set the conveyor to backwards. And the cross-sliding car I want to create based also on a conveyor. I need to move a little bit, all this stuff. I connected in direction of the material flow errors here, but also this should be backwards. Okay. To bring this, to make it running here, we already need to program a little bit. The sources create a part, and we need to move the part to the end of this conveyor. And to let it run the complete length of the conveyor. And so we need an exit control in our source. This is conveyor 3. I switch on the caption. And this is conveyor 2. Okay, I need here an exit control. I want to wait until conveyor 2 is not occupied. And then I move this part to conveyor 2. Conveyor 2 point length. This should be a comma. Oh, conveyor 3. Sorry. And I make here an interval of 30 seconds. And this should move the part backwards on conveyor 3 here. Now it would run over, in this case here, over the cross-sliding car. I renamed this as cross-slide car. So first I move this here in this position. This should be my starting point. And I need to stop the MU here in the mid of the cross-sliding car. And then I need to move this complete conveyor 2 meters in Y direction. And this I can do with the method plate translation. And so I need a sensor here in the mid of the cross-sliding car. It's 2 meters. So I want to have here a sensor at 1 meter and booking point here, not front. So it's in the mid. And I create here a control, F4. First, I need to stop the part. And then I move the complete conveyor. And the conveyor here is a question mark. underline 3D. This is all the 3D methods and attributes, and the method I need is blade translation. I need to hand over 2 points here. The starting point of the movement, in this case, is 0, 0, 0. And the end point of the movement is 0 point minus 2, comma 0. I don't want to move it in the Z direction. And then the third parameter is a speed, 0.4 meters per second. And blade translation will return the time it needs to move the conveyor here by 2 meters with 0.4 meters per second. And I can use this return value to wait for this time. And this I can check. So it's once in the mid, and then it moves the complete conveyor 2 meters in Y direction, and then I need to move the part. So I unstop the part, and then I need to wait until the part is on the end or the starting point of this conveyor. And this I can do with rest blocked. If the part is wants to move to the next element. Okay, I need to delete this, I guess. Okay. This means part will move, then the conveyor changes to rest blocked, and then I move. So in my case, it's conveyor 2. And again, we are backwards. We are transporting backwards, and so I need to specify the end of the conveyor 2 as a destination, and so it moves. So it can move all the way down to conveyor 2. Then I need to wait. Until the part has moved completely out of this cross sliding car, and then I need to move back. And this is quite the same. It's blade translation. We start here from position -2 and go to 0 with the same speed. So, and that's all we need to change the conveyor into a cross-sliding car. So one step we need to do, we need to move the part at the end backward exit control of conveyor 2 to the train. But now it should already work. Doesn't work. You need to select automatic stop here. Otherwise, it's walking all the time and not becoming blocked. And so you need to select automatic stop here in the cross-sliding car. And then it changes the state of the conveyor. So, and now we need to move the part here and the backward exit control to the drain. Controls, backward exit. I guess it's drain 1. Yes. Okay. If you need to wait or if you want to block the cross-sliding car for the next parts, then you can close the entrance here of the cross-sliding car or the exit. You need to lock the exit so no other part can enter, or you create some attribute to block the cross-sliding car while it's moving. So, and this you can use to move and turn the cross-sliding car if you need to change the conveying direction, for instance. It's only one additional method here. It's play rotation instead of play translation. There's another method, play rotation, and there you can turn the complete conveyor and model, for instance, that you need to turn this cross-sliding car while it's moving. Okay, this is the second way to model a cross-sliding car. And a third way would be to use a transporter. And the transporter itself can work as a cross-sliding car. You only need to distribute a little bit the control you need. And so I make a third example. I have source and I have a conveyor and I have a track. And again, a conveyor and a train. And I place a source here for a transporter. I duplicate the transporter here. And this should be the transporter the source creates, only one. Okay, the transporter you can use directly as a cross-sliding car because the transporter itself has different ways of load base, different kinds. So this is the matrix store type load bay. This is default, but there are two others. One is a track. If you use the track as a load bay, then you can drive with another transporter on this on this transporter, and you can create in this way transport equipment with several axes. In the former versions of Plant Simulation, the crane was built with transporters and transporters. But you can also create machine elements with this kind of load bay. You can move with transporters on the transporter, and you have the line. And this is a conveyor on the transporter, and the conveyor direction is. So I opened the transporter in 3D. So here you have the transporter, and you can go to the 3D properties, MU animation, and then I need to deactivate the animation area, and I need to have a look on the line show, and you see, okay, the direction of movement here of the line is 90 degrees from the conveying direction of this transporter, and so it's already a cross-sliding car by default in the default setting. You can change the animation here that the conveyor is in the same direction like the driving direction of the transporter, but by default it's 90 degrees from the driving direction. And so we can use the transporter directly as a cross-sliding car. So we need some information here. I need information when does a part is ready to exit from this conveyor. And this I want to make with a user-defined attribute in this conveyor. Yeah, type boolean's okay. I need a name, for instance, ready to move. Initial value should be false. And I need exit control here to set this ready to move to true. So I need the exit control. So I set here interval, maybe also 30 seconds. Yes, and then I need sensor controls here. That's quite simple. I need a sensor control to stop the transporter here. Then I wait until a part is ready to move, and then I move the part to the transporter. And then I need on the transporter a sensor control to stop the part and start the movement to the next sensor. So I start here with a sensor. I take also the booking point and F4 to create a new sensor control. And here I need to stop the transporter. Okay, this is conveyor 4. ready to move. I need to reset this value to false. And then I move the part onto the transporter. Okay, this is the first part of the control. We need to split it in several parts. The second part is on the transporter. And on the transporter, I need a sensor control on the load bay of the transporter. So load bay, you can create sensors here. Load bay length is 1.2 meters. And I want to have the sensor on 0.6 meters. And again, booking point instead of front. And I create a control here in the transporter. Add is now the part. I need to stop the part. And then I set the transporter to backwards false. And unstop the transporter to start the movement. So we can test it already. So transporting the part onto the transporter, and then it runs. And now I need the second sensor on the track to stop the transporter and unload the transporter on conveyor 5. So next sensor. And again, I need to stop the transporter. Then I unstop the part on the transporter. I can access the part on the transporter with add.cont. And then I need to wait a little bit until the part has reached the end of the load bay on the transporter. It's hard to observe. We can create an exit control in the on the load bay to create a sensor signal for this. I just wait 1 second and then I move the part to conveyor 5. I wait again. The part as exit completely the transporter. And then I move back. Yes, so I split the control here in 3 different parts. 2 sensor controls and 1 control on the load bay of the transporter. And now the transporter is moving like a cross-sliding car. Okay, it's not so nice. Okay, maybe I need to change my second sensor to booking point. This is easier for adjusting the position. And if I view, planning view, so it's easier to find the right orientation for the elements. Okay, these are 3 different ways to create and control a cross-sliding car. If you want to create this as a library element, then you need some blocking mechanism for the cross-sliding car that you avoid to move other parts to the cross-sliding car when it's moving. It's more flexible than the basic installation of the cross-sliding car from Plant Simulation. And I guess there are more approaches. Okay. Any questions?
There was definitely one in the chat.
I need to, 1 moment. Yes.
It's asking, Brian said, can you put the unload conveyor going from the right to left also? So this is a bit earlier in the presentation.
Yes. For the first one? It works in the same way. If you come from here, go to there. You need to connect this with sensor, with connector. And we need to exit control the same as here. So it works. It's only, it doesn't work if you go with backwards here on the cross-sliding car. Okay. Was this the answer you need?
Yeah, give us a thumbs up or feel free to raise your hand. You can come off mute if you'd like.
Thanks. When I've seen this before, I've tried messing around with the cross-sliding car, but like right now you've got it going from the one coming from the left going, and it just gets on the cross-sliding car, goes up and goes off to the left. Or I'm sorry, off to the right. Rather than go off to the right, if it came off the
Yep.
cross-sliding car the other way from right to left,
It's the same.
I ran into some issues.
Well, normally not. You only need to connect this. And then we need to train. And the destination is conveyor 7. Okay, let's have a try. Box.
Can you do the other one to go that way also instead of going up to have it go to 7 also?
Yes. Still working.
Yeah, it's not recreating what I had.
Yes, this is element plan simulation develops further and further, and they changed a lot of how it works, and sometimes the pull control gets out of control, and then it doesn't run in a good way, and so yeah, so maybe it's better to create your own one. And one problem you have is if you need to change the direction after transporting the part. The base here is a conveyor, and on the conveyor you cannot change the conveying direction, and so you need a point-oriented element here that you can change the orientation if you need to do this, or you need to turn completely. For instance, like in my second example. And yeah.
And that's what I was seeing is when I got onto the cross sliding cart, I wanted to go off to the left, but it went off to the right and then popped over on the left side.
Okay. Not nice. But then it may be good that you play or install the latest patch, because there are so many failures in this element, but now they have fixed almost all here. And I have patch level 20, I guess, here for 20.004. Now it's working, yeah, stable.
Next topics up. Well, first, starting at the top of the slide, that link is to the Plant Simulation Virtual User Group area of our forums. So if you haven't been there before, please go. You can click on these links right now. They'll take you there. And that is where we post the recording on Friday. So the animation there is showing you that we recommend that you click follow the topic and then select every post, which means that you'll get a system email when we post the recording, when we post the invitation to the next sessions so that you can register. And occasionally someone may post a question about one of the sessions that's happened. And so you'll be able to follow that information. Stefan also posts the models that he demos here. So if you want to get the model and that's posted, if you're following, you should get a system email. Those are the next two topics. You can also register now. So February 11th, Stefan will be back with us for material flow analysis and statistics. And then on February 25th, we'll have one of our other community catalysts, one of his colleagues will be sharing about value stream mapping, so VSMs in plant simulation. So that is there. And we do have a team if you need comprehensive education on plant simulation. There's some links so that you can click through Siemens Accelerator Academy. They also have a plant simulation associate certificate if you're new to this space. So it's definitely worth checking out if you want some more comprehensive education. You can click through there. And then my last announcement is about Realize Live. So those of you who've been with us are familiar probably with this event. It happens in this summer, and we do these in Americas. So in the US, we do one in Europe and one in APAC. The past few years have been in India. And so this is a chance to get together in person with other customers, with Siemens product teams, hear from them on the keynotes, the updates to the product, tips and tricks. There's also on-site if you need to do an education course, similar to what Accelerator Academy is offering. There's hands-on training, all of those good things. So there are links to each region at the bottom where it says learn more. If you're interested in one of those locations, you can click through and see what will be offered there and get information on what's there. So in the US, we also have a community-specific area. So the past few years, Stefan and Alex have done like a plant sim meetup there in our community area on the floor. So we should be able to do that again this year. That is my last announcement. You can see Stefan's profile and the community forums there on the screen. You can click through to that. And then that's the link again also for the forums where the recording will be available on Friday. We have about 10 minutes left, which is plenty of time for questions on this topic or another plant sim topic, because Stefan knows the answer 95% of the time. So feel free to raise your hand or type in the chat.
Yeah. Hi, Taryn. Thank you.
Hi.
Yeah, I do have a question, like it's very basic question, because I just started with this Technomatics. So, and then I've just attended today a little bit late. So I understand that you were explaining about the simulation, but what do you suggest for me, like, to start with when I'm very new to this Technomatics?
So one place
Yes.
would be here, and then Stefan can tell you in the software, he can explain everything, but do consider this. So Siemens Accelerator Academy, and Stefan will show you in the software.
Yes. You can find some materials here in the starting page of Plant Simulation.
Okay.
And there is a series of videos now. I guess it's 30 videos. And this is really a good starting point to make the videos until, I guess, 12. So these are the basics of Plant Simulation. And then you find here a quick starting guide. I hope it's running.
Okay.
Yes.
Yeah.
Yes, quick starting guide. And here there's a step-by-step help. And this is the former handbook of the software. And here you have basic lections about how to start modeling. Here are really a lot of step-by-step examples how to start here with the software. You can, and these are printed more than 2,000 pages.
Oh, okay.
Yes.
Yeah.
And then you can try one of my books. There are more advanced examples, but you should start with the basic elements here in Plant Simulation. And start with the videos and then continue with the step-by-step help. This is the best way.
Super. Yeah, sure. I'll do that. Thank you.
So I dropped the links to Accelerator Academy and also Stefan's community recordings, which is on a different link, so everybody can grab this from the chat. And then CJ gave a shout out to Stefan's book too. So, but you didn't say which one, CJ. Stefan has more than one book, so you have to specify which one was your favorite. So.
Okay, so thank you. Maybe you can visit one of my next webinars we will continue with the 2 weeks interval. And so, yeah, if you have some topics that you are interested in and want to hear in a webinar, then give me a mail. Yes, the next one, I guess, will be orange.
Yeah, so the book cover's there. If you didn't see it, is in the chat. So
Nice.
the classic,
Okay.
getting a lot of thumbs up. We'll see you guys in the forums. We'll
Goodbye.
talk soon. Bye, everyone.
Thank you. Bye.